Hi guys, my name is Steven. I'd like to welcome you back to my calibration channel. I'd also like to welcome back Maddie and Carl, my two overfitting experts. Now, if you insist on overfitting your data, I'm here to help. I know. It can be maddening to have statisticians, machine learning, and AI gurus tell you not to ever overfit your sample or model without adequately explaining what they're talking about. So I know that humans being humans, some of you are here today to do exactly the opposite of what these experts told you to never ever do. But in order for me to assist you in overfitting your data, let's first touch on some background items that we're still going to have to depend on. Okay, you rebels, let's get into it. Now, first of all, if you really want to overfit your data, then the chances are you're also trying to model a process. Many times a process can be illustrated by a graph such as this one. Here we have a series of points mapped into an XY coordinate system. Every single point in this display has two components. The X value is supplied by our measurement of an independent variable, and it's paired with a resulting dependent outcome Y. The process owners are usually trying very hard to control X in order to produce an outcome Y so that they can sell it. Roughly speaking, X is the cause and Y is the effect. Now, overfitting is going to be much easier and more practical if we speak in terms of a real sample rather than this entire theoretical data set. So here's a sample right here that is ripe for overfitting. I'm also very happy to let you know that overfitting has some very deep historical roots. Overfitting isn't just a recent meme from AI or machine learning. In fact, Joseph Fourier himself focused the earlier hints provided by Leonhard Euler about how we can overfit a sample or a model. It was Fourier who told us explicitly that given time, we can build up a function to recreate any other function all from scratch. Well, what's that got to do with us? This just means that Fourier provided the path that we can use to write a formula from scratch that not only pretty much overfits our data, that he says that we can go further and write a function that for all intents and purposes matches it so well that we can't tell the difference. Now this is the path to what I call overfit heaven. Overfit heaven is where we have tools to perfectly reproduce any sample using a formula that will work time after time to produce that exact same sample. It's unfortunate that that's all that overfitting can do for us. Once we've succeeded, we are guaranteed that our results will fail to fit any of the other data in our process because we purposely designed it to fit only this sample, even though it's going to fit it perfectly. Now I have some more good news. There's some freeware out there that will make our job of overfitting a whole lot easier. All you have to do is Google past paleontology, and you will find yourself at a site where you can download a superb free statistics package for either Mac or Windows environments. PAST is supported by some of the best technical writing on statistics I've ever seen. One reason this writing is so good is because this software is written for paleontologists who need to not only use but understand the statistics that they're using. Now, although PAST is over 20 years old, it's still being lovingly updated on a regular basis. So let's take a look at it. Let's talk about how we're going to use PAST, which is some freeware, to overfit our data. We just open up the desktop icon like this for PAST. Here it is. It's got no data in it yet. It's very easy to transfer data that I wrote in Excel and just copied in Excel. It's very easy to get it over into this platform by pressing on paste. There it is. You'll see that these commands are quite familiar to anyone who's ever used Excel before. If I want to add bands to this data so it's easier to read, I just do that. If I want to increase the resolution of my data set, I just do this. There. Now we know the first thing we always want to do with new data when we're exploring it is to plot it to see what it looks like. So to do that, I just highlight my data set like this and give me an XY graph. There are the XY data points that I created for myself. If I'd like a line portrayal of this data set, I just do that. Now I wrote this data set purposely so that there's no straight line solution that would easily allow us to overfit it with a first order equation. To prove that, we just go over to modeling and say, let's take a look at this in terms of linear models. Now here's the linear model of this data set. Here's the best solution. Here's the best solution equation for this line. Clearly, it's not touching all of our points, so we haven't overfit yet. So if generalized linear models won't work, let's talk about polynomial models. If we press on that, PAST starts by giving us a second order equation for this data set. Now here is the second order element of our equation for the line. We can't even see a curve in this line yet. I think it's slightly curved, but clearly it's missing some points. So we need to increase the number of orders in our equation. Before we leave this screen, we can see that the chi-square score is 3.79. We know that chi-square should drop as we get close to a perfect overfit. AIC should increase because AIC penalizes us for using higher order elements, and R squared for a perfectly overfit model is 1.0. So we're getting there, but we're not there yet. The next step we would take is say, give me a third order solution to this equation. There it is. Now it's obvious that our line is starting to curve. It's also missing some points, but it's getting closer to overfit. We can tell because the R squared is increased and the chi-squared is decreased. The next thing we want is to see a fourth order solution to this equation. It's very simple to do. There it is. Now we can see more and more curvature to our line. We can also see we're not touching all of our points yet. PAST will only give us a fifth order solution. So let's take a look at it. There it is. We're getting very close to touching each one of our sample points. Our R squared is almost up to 0.99, so we're very close to a perfect overfit solution. Here's our fifth order element and the entire equation for the line. This is a pretty simple way to head for perfect overfitting with no really intense calculations on our part. So if you want to overfit your data, I really recommend you use PAST. Also, I want to say that the technical support for what this stuff does is really, really powerful and really, really clearly written, because this was written for paleontologists, not for statisticians. So when you read about how this works, it's quite helpful. I recommend PAST if you want to overfit your data. Thank you for your time.